Got it? Yeah, no change in the clusters. In the fourth iteration, There is no change in the cluster. So the same cluster assignment remained. What happened in the previous one? No change. Yeah. Hmm. Where? Python questions. So when importing it, it's like unnamed columns. Where? One open is Excel sheet. Okay, okay, this one now. Oh, okay, okay. Delete them. Mhm. Okay. Okay. So we have customer ID, gender, age, annual income, spending score. We need to label and code gender. So mall data is equal to pd dot get dummies mall data, comma, columns is equal to gender. Mall data dot head. See, you got gender underscore female, gender underscore male. Mall data is equal to mall data dot drop customer ID. Comma, access is equal to 1. Okay. From sklearn dot KMeans cluster import KMeans. So we'll be using optimal, we'll be finding the optimal K value using WCSS and we'll elbow plot. WCSS underscore list is equal to null brackets for I in range 1, 15 colon K means is equal to K means n underscore clusters is equal to I, comma, K means dot fit mol data WCSS underscore list dot append KMeans dot inertia. So each iteration will take values from 1 to 15. I value will range from 1 to 15. So generally we use K-means n is equal to cluster is equal to 2, 3, 4, 5, right? Instead of that, we given a range of values. The iteration will run. Each range of values will be fitted. For I is equal to 1, 2, 3, 4, 5, it will do. And it will also add the inertia for each of the model to this list. PLT dot plot range 1, 15 WCSS list Got it? So where is the bend happening? 6. Ignore it, no problem. It's only a warning. Okay. Now, if you go to the elbow plot, you can see there is a clear kink at 6. The elbow, right, is happening at 6. Now, we will build our model at 6. Model is equal to K-means n underscore clusters is equal to 6. Model 6 plus is equal to model dot fit mol data. Okay. Model 6 class dot cluster centers. These are the 6 cluster centers. 1, 2, 3, 4, 5, 6 cluster centers. We got these are the centroids. So cluster 5, 45 observation, cluster 1, 39, 38, 35, cluster 0, 22, cluster 3, 21 observations. So you can see the labels, how many observations in each clusters. We got the cluster represent. These are the centroids for each cluster. 1, 2, 3, 4, 5, 6 centroids. 6 centroids for 6 clusters. Right? And then these are the labels. Which observation is assigned to what label? We have this many representations. Cluster 5 has 45 observations. One has 39. This from sklearn dot metrics import Silhouette score. Silhouette score mol data comma model 6 class dot labels. We got 0.45. So if we give at least one shot, let us have given 5. See, the silhouette score will fall. If I give it as 7, it falls. It has to be the exact from the elbow plot. The elbow plot is indicating 6. Now, 6 is the point where you have a proper elbow kink. So 6 is giving us a good classification. .45. So here and there also will cause difference in the cluster formation. So you have to be very careful when you are choosing the clusters in your model. You have to be very careful in choosing the optimal number of K value. Optimal K value must be found from elbow plot. If you have doubt, like you find it, like I said, no, +1, -1, +2, -2, build models and see the Silhouette score. So I have done 5 cluster, 6 cluster and 7 cluster. The best cluster score is 0.45, which is coming at 6 cluster. So we will go with 6 cluster as our optimal K value. Sometimes what happens is you will not be able to be clear like this. In real-time data, when you have this is small data, 200 observations only. When you have very large data, it will be non-linear. Lot of things will be there. So there you might see elbow might be representation by 3 or 4 numbers. You might be get confused. right? Like I showed you in the one of the plot here. See here. Which one will you take? Technically, this should be the one, right? 5. But look at the 6 and 7 also looks to be very close to 5. When sometimes you will see this problem. Is it 5, 6 or 7? Then you have to build a model, calculate the Silhouette score. Then only you will come to know the values. Otherwise, you will not be able to find the values. Okay. So in real time, large scale data, you will have this problem. You may not be able to find the exact K value. Then you build the value models with different K values, and the one which has the highest Silhouette score will be your best fit model. Clear?
So it would 7 we got greater value.
Lesser value for 0.44. 0.44. 4391. 7 cluster. 45176 cluster. So we have to give 2 points, right? Why are we getting another?
Sir, after annual income, you haven't closed out the square bracket.
Sorry. Thank you. So these are the clusters 1, 2, 3, 4, 5, and 6. There is a overlap. See, yellow and orange, this is the problem. That's why we're getting a low Silhouette score. There is some overlap happening here between 5 and 6, but other clusters are distinct. Overlap is between 5 and 6. So this is the problem. So that's why we are getting a low Silhouette score, less than 0.50. Hmm? That's what. Less than 0.50, we'll take it as closer to 0 only, right? Above 0.50, we'll take it as closer to 1. Okay. Now, if we run with less clusters, what will happen? You can check it. Let us say 5. Oh, 5 is giving us distinct cluster formation. Overlaps are not there, right? Oh, 5 seems to be better. Even the silhouette score is less. This is another problem you will see in K-means. Sometimes the cluster formation for the lower silhouette score will be better than the other one. So if you see here, this is the classic example. 5 clusters, we got distinct formation, no overlap. So I would go with 5 here. Even though the silhouette score is marginally less, but still we are getting a clear cluster formation here. Whereas 6 is giving us overlap with high silhouette score. So you have to be case based. For this problem only DBScan is developed, density based clustering. In DBScan, we don't need to give the K value. There is no something called K value. It will do based on densities. Densities means same distance only. Group of highly dense clusters and low dense clusters. So DBScan is an advanced algorithm, which is developed by Google guys only. For large scale clustering, we use it, where we don't need to give K value. For K-means, this is the problem. You find if K value is the issue.
We have to see the cluster formation that
Only cluster formation if you want to see. See, cluster formation also we use in market segmentations, customer segmentation. So generally projects in clusters are market segmentations or customer segmentations, mostly customer segmentations. Customer loyalty and all those places where you have this loyalty programs and all, you have to find very loyal customers, medium and high low customers will be there. Their clustering is widely used. In banks also, they use it to give offers and discounts, right? Not all customers will get the same thing. It depends on the clustering done in the backend by the algorithm. The DBScan algorithm will give you a more better thing. But some basic data, K-means also gives you good one. K-means works on large scale data also. It works on large scale data also. It has effective. So, but you have to do a lot of trial and error work in case of K-means.
in real time, what about that K-means and
Which one? For the segmentation, we use K-means and K-neighbors. So the difference between K-means and K-neighbors is K-neighbors requires a dependent variable. K-means does not require a dependent variable. So this is again a common interview question which you will see. K-means does not require a dependent variable, but in K-neighbors, you must require a dependent variable. Both are neighboring or grouping algorithms. Both are grouping algorithms. K-neighbors also grouping, right? Based on what you call Euclidean distance, group it into neighbors. KNN is again a supervised learning algorithm. K-means is both supervised and unsupervised, but predominantly unsupervised. Predominantly used in unsupervised learning. It does not require a dependent variable, whereas KNN requires a dependent variable. So, see, K-means is predominantly used. You can use it as a supervised also. If you have dependent variable, or you don't need dependent variable at all here. So, we generally use K-means on supervised data like segmentations, customer segmentation, market segmentations, grouping related activities. We use cluster on supervised data also. So in this case, 5 cluster is doing better compared to a 6 cluster because we got a clear segmentation. So we will go with 5 cluster and marginal difference in silhouette score 4517, 4438. Marginal difference, not big difference. See, it all depends on the variables we take for scatter plot. Here we have taken annual income and spending score, right? Generally, in large data, you have multiple numeric variables, right? So it also depends on the type of data you're dealing with, numerical, categoricals. So how do we classify categoricals? We don't do scatters, right? Categoricals, we don't do scatters. Scatters, we have to do only on numeric data only. Okay.